I have the iCEBreaker here, and I will be using the quad HyperRAM PMOD with it. But before doing that, what I'm gonna do is just run the memtest bitstream that I have for it, using that board, using that board combination. Check that it actually works before I do anything with it. Currently, it's not plugged in because I have no idea what bitstream is currently running on the FPGA, so I don't want to plug the HyperRAM into, you know, random logic that I just happen to have on the iCEBreaker at the moment. So I'm just gonna do this very quickly. So I'm just gonna I'm gonna start a fresh clone of my thing here. While we have a few minutes, that should be enough to run this minicom. Oh, no, I don't need that actually. Okay, so let's put it background. Should have a somewhat recent toolchain, so that should be good. If that's a problem, we can just download the pre-built binary from the Yosis HQ, but I don't think that's going to be necessary. Project, memtest. I want to make board iCEBreaker mem equal HyperRAM. Oh, you know, actually, so by default, this memtest tries to run the memory pretty fast at 147 divided by 2 because it's the final clock ends up divided by 2. So it tries to run it at like 70 megahertz. There is absolutely no way in hell that we're gonna run a Linux capable Vex RISC-V on an iCE40 at 73 megahertz. That's just not gonna happen. Or even half of that actually. At 36 megahertz, that's not gonna happen either. Like the Vex RISC-V on an iCE40, like the basic configuration runs at maybe 25 megahertz if you're lucky. Like it passes timing, it can get faster if you overclock, of course, but it passes timing at like 25 megahertz maximum. I'm gonna probably target somewhere around 15 megahertz because we have to add an MMU and a bunch of logic and stuff like that. At the moment, I have no idea if it's even gonna fit, right? But we're not gonna run definitely at that kind of speed. So I want to run the memtest at the target frequency that I'm gonna have here, which is gonna be 15 megahertz. And if I want the system to run at 15 megahertz, I need to set up the PLL 4 times faster because of the way the HyperRAM controller works. It needs 4 times the clock frequency, which means I'm gonna run it at 60 megahertz. So I need a PLL configuration. OPT, OpenFPGA, okay, iCEBreaker. We have 12 megahertz input, 60 megahertz output. That's the configuration I want. And I want to run the memtest at this frequency. So the way the HyperRAM controller works is that it actually runs the HyperRAM at twice the frequency of the system clock. So if we run our CPU at 15 megahertz here, the HyperRAM is gonna run at 30 megahertz, but it's DDR, and so because we need DDR and a 90-degree phase clock, we actually need the PLL to output 4 times the frequency, the system frequency, so 60 megahertz. Okay, so we have diff R0, diff F is gonna be this thing. I think that's good. And the other thing I need to adjust is the divider, which by default is 16. Why is it 16 by default? Anyway, the frequency is going to be 60 megahertz. I want it to run at 2 megabaud, which means I need a divider of. No, never mind. It runs at clock 1x, so it runs at 15 megahertz. Okay, I'm gonna run it at 1 megabaud, so I can divide by 15, and I know I need 15, 13. I need the divider minus 2, just the way this thing works. Where's the baud rate? It's gonna be 1 megabaud. This is just preparation stuff. I'm just trying to see. Can you not run Linux without MMU and RV32? I don't think so. I don't think anybody has written support for that, and I don't really intend to try to do that. The main goal here is just gonna basically try to take the port that's usually run the Linux on Lytix Vexus 5. I'm not gonna run on Lytix, but I'm gonna run on the Vex, and that's more or less a known working configuration. So that's gonna be my starting point. There is no MMU-less version of RV32 as far as I'm aware. I mean, if you can Google and try to see if there is one, but I don't think there is. And that's definitely not what I'm gonna be doing today. Trying to port that to MMU, that's way above. Okay, so I can build the memtest bitstream. Then we call hyper. Oh. Yeah, that was fast. Program the board. Playground, project, memtest. Memtest, HyperRAM. Really? What the hell? So it's not P serial? Or is it just serial? I'm not sure that was it. I don't think that was this serial. Damn it, I forget it. I have it installed on my laptop, I just don't have it installed on... Okay, so that's... uninstall? Wait, actually? Yeah, I thought, but I did install PySerial. Like I did pip install PySerial. Requirement already satisfied. And then Python import serial. Oh, wait. What? I'm kind of confused as to... Yeah, no module name serial. Do I need to? Okay. Pip install py serial. Okay, never mind. That worked. Okay, so that's a bad start. Is that it doesn't actually. Yeah, I don't know what was. I think it's because this explicit. Oh yeah, okay. So this is actually wrong. This shouldn't call. This should code. Yeah, I think that was the problem. That's why when I started it with the interpreter, it worked. Okay, never mind. Whatever. Anyway, it's. Oh yeah. I was gonna say it's a bad start. Like it fails completely the memory test, but yeah. See, I kind of forgot to plug in the PMOD, so obviously not gonna work. So let's plug the HyperRAM. Hopefully the mem test is gonna work way better with the actual memory plugged in. Yeah, that's much better. And it's performing the mem test, and yeah, that works way better. And I mean, you can see that basically no matter, like we're running at such a low frequency that it doesn't really matter. The core configuration is just like the training works basically for every single thing. We might actually need to remove, I don't know what size if we're gonna have some spare space or if we're gonna need to grind for every lot, but we can actually simplify the HyperRAM controller and remove a part of the configuration. Like here, it can basically, dynamically tune the read phase delays. It can capture on either edge dynamically depending on the delay and stuff like that. Here, we're running at such a low frequency for HyperRAM that we can probably strip half of that away and it's gonna work just fine. So if we have a trouble with size, we can try to optimize that. One thing at the very least is that I'm gonna save this, basically, which is the configuration that it found, so that we don't actually need to implement memory training. And we can just statically load the HyperRAM configuration. And so we're testing four. So that the quad HyperRAM PMOD, it's assembled with 64 megabits chips. And so 64 megabits chips, four of them, that's 256 megabits, which is 32 megabyte of RAM, which is pretty much exactly what we want for the default configuration of this Linux on LightX Vex thing. All good. Okay, the HyperRAM works. We can actually start doing interesting things. So the maximum theoretical throughput at this frequency is good question. So it's running at 60 mega transfer per second, 30 megahertz DDR, and it's 8-bit, right? So, well, I mean, that's basically 60 megabyte per second. Yeah. Which isn't, very high, but it's also not terrible. Honestly, one thing that I expect is going to take the most time in the boot process, if we even get to that point, is loading the image from the SPI to RAM, because to save lots, I'm not gonna put a very complex SPI controller. I'm gonna use the SPI controller which is built in the UP5K, which is the hard SPI IP, which is nice because it consumes basically no LUTs. We just need a tiny bit of bus interface. It's also slow as hell. So like I know the rootfs image plus the kernel is gonna be like 8 megabyte or 10 megabyte of data to copy. And this is definitely gonna take some time. Okay. So we can get started. Something I did before the stream is I downloaded. Basically, I went to Vex Linux thing here, and because I know we're gonna need to rebuild the kernel ourselves, we can't use any of the pre-built images because well, the hardware is completely different. And so I did this because I knew that this was gonna download like 15 gigabytes of things and compiles a bunch of stuff like the root file system and the kernel and stuff like that, and I wanted to have all of that pre-downloaded, and it took like 30 minutes. So and especially downloaded a lot, which would have been pretty bad if I'm streaming at the same time. So I did that, and I ran it, and it's in the build root here. I have like I don't know how much, like 11 gigabytes of stuff downloaded and built to build like an 8 megabyte image, which is just whatever. But so that's done. But we will only get to that later. The first step is get a SOC which is potentially capable of running Linux. So that would be the first step. So I'm gonna start from. I'm not very sure what I'm gonna start from. I have two options basically. I think if I go to my stuff, I think I have a dev branch, which is yeah, I did add clocking generation. So because in that dev branch I have a few commits which are pretty old. Oh my god, they're like 1 year old. But I was running the PyCoreV with the HyperRAM controller. And I'm not sure if it's gonna be easier to start from this, or if I have a better chance of starting from the Doom SOC, which oh wait, did it actually pop up an alert? I didn't see. I wasn't looking. I did configure Streamlabs, I think. Actually, wait. The comments are not showing up, are they? I didn't pay attention, but oh yeah, okay, there was. Okay, perfect. I don't actually hear the sound here locally. I should definitely configure that. I did reconfigure my OBS with the browser plugin so that it's easier to do that kind of stuff. Oh yeah, I do see the chat now. Okay, perfect. So yeah, the question was, do I start from this? But this is only the PyCoreV, and I don't want to use the PyCoreV. I want to use the Vex, which doesn't help me. Or what I think I'm gonna just do is start from the Doom stock, because the Doom stock has a lot of what we need. It has a Vex RISC-V. It's not the right configuration, but we can reconfigure the Vex and basically keep the same interface. It has the cache implementation for the iCE40 is plugged in. It has the bridge for between the cache and the Vex. It has a QSPI controller and the SPI-RAM controller, but that controller actually has the same interface as the HyperRAM controller. I mean, I wrote both, so I wrote them to be basically interchangeable. So it should be easy to disconnect one and connect the other in its place. So I think I'm gonna do that. And I'm gonna copy the HyperRAM controller from the memtest project, basically. So let's copy -a RISC-V Doom, RISC-V Linux. Okay, so I'm not gonna need QSPI master, but I'm gonna need HyperRAM. I am not gonna need any of the video stuff because I don't care. I don't have video output. I'm not gonna need the SPI flash. I'm gonna keep that for now. I don't know if I'm gonna need it or not, but we'll see. Okay, I'm good there. Let's see the source. I don't need the frame buffer. I don't need the palette. I don't need the video top level. All of that can go. So the first step, I'm just gonna try to connect the HyperRAM controller to the VEX and boot like a hello world or something, and get that building. I'm actually gonna go there. Let's see. Yeah. Oops. No, that's not what I want to do. Yes. I don't like this environment. Okay. Just want to be able to type here make and so that it builds in that console. So let's start editing the top.v. Okay, we don't have any video. We only have one SPI and it's not going to be wired to the SPI controller. It's going to be wired to something else. We don't have a QSPI PHY signals. We have boot memory. We won't have QSPI. We'll have HyperRAM. Definitely won't have video. The HyperRAM controller is going to be connected to Wishbone 0 because we need to configure it. UART is going to be 1. I mean, we don't need LED, and it does consume some logic to interface it to the LED, but I'm still gonna connect the LED just to. If we run out of space and we really need to save every single thing, I will wire. Actually, let me leave it on 3 because we're gonna need an SPI controller to load the orbit stream from SPI. Hey, hi, Chad. Welcome to the stream. Yeah, and SPI, we're gonna wire that to 2, which means that we have 4 devices. So I need to set WVN to 4. Okay, perfect. It's already set up to that. Okay. So what I'm gonna do is copy basically the stuff over from the memtest project, because the memtest project has the HyperRAM IO. And should have the HyperRAM controller. RAM. Okay. RAM cache request, memory interface, revert. I don't want that here. Verify. Okay, I don't, yeah. Currently, when I wrote that code, I wasn't yet formatting. I like having them aligned. I wonder if it's possible to write like a Vim plugin or something to automatically format that kind of stuff, because it is kind of annoying to do manually, but it's kind of, yeah, it's a bit of yak shaving, right? Trying to implement that in Vim myself. I'm having a look at what those signals are at the same time to see if I need to change some stuff. I think I will definitely need to change some stuff. Yeah, okay. Maybe I should at some point just look if there is one that exists that can do it for me. Okay, so one thing we need to change is here, WV data, maybe this. Okay, we're probably gonna need to fix that. And definitely this, because we want the 4 chips in the memory test, like the memory mapping uses the MSB of the address to know which chip we address. Here we want the 4 chips to appear as one contiguous memory zone. So we definitely need to fix that up. And I need to remember why there is only 1 bit here and not 2. I think it has to do with the HyperRAM, the way HyperRAM is addressed or something. I probably need to open the HyperRAM datasheet and read, because we run the HyperRAM at twice the system frequency. No, actually that's because the DDR, I think. Because it's DDR, the internal memory is 16-bit wide. So every address that we give is it's not a byte address, but it's not a 32-bit word address either. It's literally a 16-bit word address. That's probably why there is a 0 there. Yeah, something else that's specific for the HyperRAM that was not in the QSPI and that I will need to transplant as well is this R. So the controller works with the system clock, the 1x clock, then a faster clock to clock the PHY and stuff like that, which is a 4 times clock, and there's also a clock LD, and that's because HyperRAM has when the data comes from the HyperRAM to the FPGA, we don't, it doesn't have a fixed place where it is. There's basically a strobe, and so we need to kind of tune the memory controller to capture at the right time. And so the clock LD is actually a 4x clock. It's at the same frequency, but it has a variable phase. That's what the HyperRAM training does, is basically try all the possible phase and find the one that works the best. So I have this clock LD delay. Yeah, I have this. That's the signal that goes from the HyperRAM controller to the PLL to be able to select them. And then we also have sync signal. The sync signal is it's a pulse that happens once every 4 cycles that tells the PHY when to transfer, on which cycle to transfer data between the 1x domain and the 4x domain. Okay, and all of these are generated by this, and well, that's actually not the case at the moment, but we're gonna make it the case. I'm just gonna copy the system manager. I mean, this is obviously wrong, but that's only used for simulation. If we need to set up simulation, I'll need to fix that up for the sync LD, but yeah, at the moment we don't need it. So what am I missing? I'm missing the SPI controller. And I need the clock generation. So the SPI controller, I can just take that from this project. Wait. SPI, perfect. Boom. We don't have PSRAM. I mean, technically we do, but we're not using it, so... did I name SPI Flash CM? No. Okay, and we're on port 2, perfect. I think we're good here. So I just need the clock generation now. This manager, and I'm gonna take that from the memory test project. Okay, what's this manager? There's nothing very complicated here actually, because a lot of the complex parts are encapsulated in we're gonna run at 60 megahertz, what I said earlier. We're not using SPI, we're using HyperRAM, so we're gonna use this. And there's a bunch of stuff that you need to do for the clock, for the HyperRAM controller, but it's kind of encapsulated in a block where you basically just give it, you know, what you want, and it will generate it for you, so you don't have to worry too much about it. I'm just gonna align. That's fine. Okay, so on that front, I think we're good. I think this should build. Did I miss? Okay. It obviously does not. Okay. Oh, okay, yeah, I see. It's because the previous SPI controller was a quad SPI controller. This is not, so I'm just gonna take this. Take the SPI port definition from there as well. Oh, we need the PCF. I forgot that. Need to set up the clock. So 15 megahertz. Here we're actually gonna try to meet timing. We'll see if that's possible or not, but I'm hoping at least we can meet 15 megahertz, and even if we need to overclock a little bit. And we also have clock LD, which is clocked at 4 times the clock frequency. And then we need top iCEBreaker, and I need does this a way to display the model structure and graph might be nice to show during the stream to give viewers an overview of the things that are building. I don't know. I mean, I can do use this show, but use this show is gonna show way more than what you want, because you'd basically want to only have the modules, like the hierarchy, and I'm not sure how you would do that, because you don't want to dig into like all the details. You just really want to see like up to the leaves, basically. I do have yeah, I didn't actually plug my Yeah, I don't think you can do that for the Verilog mod. I mean, the thing is, for users, if you do a show before the hierarchy flatten, it will show you the modules, right? Because that's just the way users works. Is that when it first loads the design, it sees it as a hierarchy of module, but one of the very first step is actually flattening the whole netlist, so that it can optimize across module boundary and stuff like that. But if you do a show before that, it should show the modules, but I don't know how to specify like a maximum depth or something like that. I mean, something I can do, like for instance, if I do use this, okay, if I do read verilog rtl sub.v, what now? What? What does it need clock 2x for? Alright, we don't need clock 2x actually. Okay, can I get it to read that? Yeah, okay, it read it. If I do show now, I mean, it does show the modules, right? But it sort of shows all the net connection as well. Like, you only see the first top modules, like you can see the vex, but it's not very well arranged. Like, good luck understanding that, right? I mean, you can see that as modules are concerned, you have a vex risk 5, which is connected to this thing, which is the sort of the nose bridge, if you want. And that dispatches all the memory request from the vex to a tiny bit of VRAM so we can boot, and to the memory cache core, and to wait. Okay, let me see if I can quickly just connect my remarkable, so I can draw a diagram that looks like something instead of just this. I need a micro USB cable though. Okay, found a cable. You wire that up. I haven't actually tested if my stuff for the remarkable still works or not, so maybe kind of a surprise here. Do I have quick sheets. Okay. And I'm trying to see if I can connect to my remarkable to get the screen grab like I did on some of the streams, but I didn't prepare that in advance. Yeah, the SSH key changed. Nah, sorry, that's doesn't seem to be working out of the box. At least the way I saved it isn't. It should still. Oh, okay. I need remarkable deck. Okay. Sorry. Okay, so that's I got it running. Can I show that on stream now? How does that work already? Okay, that works. Let me just wipe that off. Okay, so the basic sock we're creating right now is yeah. So I'm trying to see where my cursor is. With the Vex, and the Vex has two interfaces. It has a instruction AXI bus, and it has a data wishbone bus. Now, why is it like that? Is because the data wishbone is single access mostly to the data and to the peripherals, while the instruction AXI bus is used in burst mode because the Vex has an internal instruction cache, which I'm using, and I'm not using the data cache. That's just because the instructions are read-only, basically. So it doesn't matter if the Vex isn't a write-back cache, but for data it does. Both of these are connected to... Actually, maybe I can show this in dual mode. Yeah. And use the top at the same time. So we have our Vex CPU here, and we have the instruction bus, which is AXI, and the data bus. Okay, both of they're the main interface. The rest is clock and the interrupt stuff. And then we have this thing, which basically has the same AXI interface and the same data bus, and that's named the MC bus Vex, which is a memory cache bus Vex, basically. So that's the Vex. That's the MC bus Vex. So it has the instruction AXI bus slave and the wishbone slave for the data wishbone. And what this thing does is it basically splits the address space into several parts. Everything that starts with with the MSB set, basically, so 0x8 0 0 0 1 2 3 4 to 0x f f f f or the all f. This goes to the peripheral bus. And that's a wishbone bus. And on this bus, we're gonna find UART. We're gonna find the RGB LED controller thing so that we can blink stuff, and we're gonna find the SPI controller that's built into the up5K. So it's not memory. It's not a memory mapped SPI controller. So you can't access any memory in the SPI flash or anything like that. It's a command based. So you tell him to transfer a byte and read back a byte. It's like a SPI device on a microcontroller, right? 07? Oh, is that a tool or something? And then we also find the HyperRAM controller on that bus, and that's the control interface of the HyperRAM controller. So, as I said, you need to configure the HyperRAM, do things like oh, hi. Okay, I didn't understand that it was a. Oh yeah, I guess the 7 is like the wavy hand or something. So it has the HyperRAM controller has a control port, and it's on the peripheral bus. And that's this giant thing, right? We have the wishbone bus to all the peripherals, and then we have two more ports. The RAM port, and the RAM port is a very small zone of memory, which is, I think it's 4K, and it's mapped at address 00. And that's a tiny bit of BRAM. And you can see it basically as the ROM code of the thing. That's what gets executed when you boot, because you can't initialize HyperRAM. When it comes, it's first you can't access it because the HyperRAM controller isn't configured, and it's also not loaded with anything, so you can't execute it. So you need a ROM code, and that's this port. And the other port is the request and response that go to the memory cache controller. So you have the memory cache controller, and this is mapped at 0x4, 1, 2, 3, 4, 5, 6, 7, up to 0x7, F, 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 F. And there's actually two connections. That's a pipeline bus where you have a response and request. So you send request, and then 3 cycles later you get the corresponding response. No, so that's the boot memory, as I said, and then this is the memory cache core, which, as I said, has the request and response connection to the bus interface. Currently, we're configured with 64K of cache. We'll probably bump it up at 128K because we really have nothing else to do with that memory. I copied that from the Doom project, and in the Doom project, we use 64K for cache, and we use 64K as video memory. We don't have video memory, so we can probably bump it up to 128. We'll do that later. And the cache has an interface to the MI interface, which is cleverly named the memory interface, which basically connects to the HyperRAM controller, and that allows him to submit commands. So at a given address for a given length, you do a read or a write, and you send basically a command. Okay, I want to read 32 bytes at this address. And then sometimes later you get them here, or if you say that you want to write 32 bytes at this address, you get them ready on this bus. They're basically like AXI stream bus for the write data, for the read data, and for the commands basically that you want to send. So that's the connection between the cache and the HyperRAM controller. Then you have the HyperRAM controller. And then the HyperRAM controller connects to the HyperRAM PHY, because the controller is generic. It can run on any FPGA. The PHY is very, very specific to which FPGA you're running on, and all the dirty tricks that you need to do on iCE40 to be able to run this on iCE40. And then the HyperRAM PHY actually connects to the HyperRAM PMOD, basically. Then in the rest of the file, you have the UART where we explain that. So the peripheral bus, you've got the SPI, you've got the LEDs, and the rest is just generating all the clocks that you need for the system. So that's basically the general top level overview of the SoC we're building. I mean, the HX doesn't have enough embedded RAM. Yeah, it doesn't have the SP RAM, right? But you could still probably build a small cache, probably of like 16K, like dedicate half of it, and still do something with it if you wanted to, if you really wanted to. But yeah, anyway, I hope that the like top level overview of the SoC is clear to everyone. Yeah, Jared. Yeah. Unfortunately, Linux kind of changed between those times, and it has become way heavier. That's kind of the unfortunate truth. But speed-wise, compared to a 486, the memory is faster. It's probably gonna be half the speed of that, most likely. Half to a quarter of the X266, like purely from a computational point of view. Although, yeah, I don't know. We're gonna need to strip a lot of things. I'm just comparing to the Doom thing. And we're gonna need to, yeah, definitely strip it. Anyway, let's go back to trying to build our actual SoC. Is that? Yeah, for some reason I named it with underscore in another project, and I keep confusing the two. I mean, Peter, here you kind of have a hierarchy of the stuff in kind of text form, right? It's not a graph, but it's not bad either. Okay. W Act 2 is multiple driven by. Okay, so I screwed up something in the peripheral mapping. HyperRAM is 0. That's correct. Okay, yeah. UART is on what's 1. SPI is on bus 2. LEDs are on bus 3. Oh no, we wait. While it's building, I'm just gonna go grab something to drink. Because I speak a lot. So wait. Oh yeah, the PCF. I didn't finish the PCF. I need the pin mapping for the HyperRAM, and I can take that from the memtest data. So let's break it out. Memtest data top iCEBreaker dash HyperRAM thingy. Yes, perfect. Okay, I also don't need a mapping. Oh yeah, I need the mapping for SPI as well, actually. Okay. We don't have HDMI anymore. Quad HyperRAM. Yes. All the HyperRAM. Quad HyperRAM. And then we need the SPI, and we can take that from the NUSC file, USB, data, top, speaker, SPI, boom. And we wait. Yeah, the problem if you grab an old kernel is that the old kernels don't support RISC-V. Well, we might have to kind of maybe not exit it, but do our own bootloader because I have absolutely no idea how Linux boots on RISC-V. Like the boot process, like do I just copy the binary and jump to it? I know that to boot Linux on a FP, you have to do a bunch of setup before that. If you want to boot Linux on an ARM, you need to pass a structure at a given address and set up some registers in some way before you can't jump to it. You also can't place anywhere it in memory. You need to place it at some specific space and a bunch of stuff. And I have no idea how that thing works at the moment. So, okay, so it works. I mean, no, sorry, it doesn't work. It built something. I have absolutely no idea what the firmware boot actually does, which is bad because obviously we needed to do something completely different. Okay, so that's not good at all. Currently, the boot firmware that I have here is set up for the QSPI controller, which is just not gonna work. So I wanted to set it up for SRAM, for SPI, sorry. So what do I need to do? I have well, basically the one from the RISC-V the RISC-V USB project does that. So I can just copy it. RTL. No, firmware. boot.s. Okay, so that's gonna make it. ROM, so that's correct. boot.s. Okay. So we're running at 15 megahertz. 15 megahertz, we want a 1 megabaud UART, so we need 15 minus 2 because the divider is, you don't put the divider, you put the divider minus 2 in the registers. And I am definitely going to enable boot debug to see if things do anything at all. Okay, the thing is, like, there is absolutely no hope that we would, have a debug module. Like, we can't. The Vex has a debug module option, right? We'll be lucky if we can fit a Linux capable Vex in the UP5K. There is no way we fit it with the debug module enabled. So the only debug we're gonna have is print. That doesn't get us anywhere. At some point, we might have to set up simulation, but simulating iVerilog to boot Linux is gonna take forever, which means we would need to set up either iVerilator or more likely I would set up CXX-RTL because this is preciosus. But you're not gonna simulate HyperRAM with that, which means we would need to do a bunch of stuff. I'm hoping that because all the modules I'm using at the moment, the only thing I'm doing is plugging things that are already tested together, right? I only modified pretty much the top level, which means I'm not debugging any of the RTL really. I know that RTL should work. So the only thing, okay, so here I'm not sure if I don't know why I didn't do it before, but what I'm gonna do here is UART space Rex84. No, wait. Where did I put the UART? Great, thanks. Okay, 81. 81. 1, 2, 3. Yeah, I know I don't technically need to reload it. I just Okay. Oh, actually, I have SPI biased. SPI biased. Okay, I'm making. Is the SPI connected to bus 2? Yes, it is. Perfect. So what this basically does is it copies 64K from the flash into memory, which isn't gonna help us at all because we don't have any memory. Okay, how did I forget that? We don't have any memory. I mean, we have memory, we have HyperRAM, but we need to configure the core before we can use the HyperRAM. So we basically need to add code here to set up the HyperRAM first. Okay. Guess we can do that. So that's why I wrote down this, the result of the mem test, is because I'm not gonna implement memory training here. I'm just gonna copy the result of the memory training. And to remember, actual support for the memory controller. Oh, great. The thing is, I have this in C, and I can't execute C because I don't have a C runtime environment here at this place, right? So I just need to manually set up everything, but that's not very complicated. All I need to do is set that command latency to wait it on. We need to translate this to assembly, basically. Okay. Do that then. I think I put the HyperRAM controller as device 0, right? What is that? HyperRAM 0, yeah. Did I call it HRAM? I think I called it HRAM. No, I'm just gonna try to first boot that. Just this. It's not gonna do anything except print something on the console. But I want to make sure that we get at least that far. Wait. No. What? Why don't I? Oh no, never mind. That's correct. I was kind of confused by the layout, but that's fine. FPGA, and because I want iCEBreaker. Okay. Should be A, B, C, or maybe just A, B, I don't know. At least A. And we don't see anything. Okay, that's not a great start. Why? I did define boot debug, right? Yes. I did define boot debug, which means I should set up the divider 13 and output A. So why isn't it? I'm just gonna make it in a loop just because sometimes the first character to be output after configuration doesn't work for some reason. It doesn't detect it as. Why didn't it detect it as changing actually? Okay. I didn't even check like, oh, what was the FPGA? What are we starting with here? Because the moment the vectors that we're building is not Linux capable, right? It's yeah, there is no iDroid button. I haven't set up that yet. I set up the alerts and the chats. I'm not sure how I set up the like I don't even know if you receive like what are these? What are the things that do you receive channel points or do I have to enable that? Like okay, so it prints. Okay, much better. Okay, I'm how do I stop it now? Because this is just too much. Can I unconfigure the FPGA? That's why a reset button would be useful instead of shorting the contacts here. Oh yeah, but if I short reset, it resets, of course. Okay. Anyway. Yes, exactly. I mean, it never looks like much, but that means that there is a lot of things that have to go right for that to work. Like the VEX has to work, the clock generation has to work, the main bus interface to the ROM has to work. We don't have HyperRAM yet, but one thing at a time. Now getting HyperRAM running. And so for that, we're gonna implement this method, HyperRAM boot, HyperRAM init. Well, first we're gonna set that up to copy. Wait, jump. The main code is gonna be at 0x400. That's gonna be 1, 2, 3, 4, 5, 6, 7. Okay, that's where the HyperRAM is gonna be mapped. I have no this is an instruction. I don't remember what that does, to be honest. I'm gonna just remove it. Okay. One of them is the destination. One of them is the length. I think A1 is the length. A1 is, oh yeah, okay. I actually documented it. Wow, destination pointer. Okay. We're copying everything to 0x400. That's where our HyperRAM is going to be mapped. at some point in the near future. Blah blah blah. HyperRAM. So let's look at this code. So okay, the HyperRAM controller doesn't have a whole lot of. It has CSR. I'm trying to remember how the HyperRAM controller works, right? Because I wrote it like a while ago. But it basically has 4 registers, right? Which is not too much. So what I'm gonna do is equal 0, 4, VQ data, 8. Okay, that's basically a register map. The register map that the register will need to access. We don't need to do much. We pretty much only. I can just copy that actually. Yeah, that's fine. Oh, wait, did it? Let me actually try to separate things a little bit because I'm getting lost here. Let's be like. I completely forgot that I couldn't use that C code, and that I would have to rewrite it in assembly, honestly. Yeah, it's always a surprise when I wrote documentation. Oh wow, what the hell was going on? Okay. Blah blah blah. Yeah. So that's annoying. I know it's yeah. Okay. I'll have to write the control word. But I will probably. Yeah, CS0 is really what I need. So we have 2 things to configure. We have to configure the controller itself so that it can talk the HyperRAM, and we have to configure the HyperRAM chip itself. So the actually, let me take the datasheet for the HyperRAM chip. The HyperRAM chips have I don't know which chip I have, but it doesn't matter. Yeah, just give me the. I want the datasheet. Okay. Wait, that's where I was. Oh, okay. Here. There. They have a configuration register which sets some parameters like the delay it has, the drive strength of the driver and stuff like that. I think it's called CR0. Yeah, CR0. And we need to configure that configuration register 0. The 16-bit registers that we need to set things up properly in it. So we need to first configure the HyperRAM controller, and then instruct the HyperRAM controller to go into manual mode, basically where you manually send commands to the HyperRAM, send the command to the HyperRAM to configure CR0 so that it configures the chip. And we need to do that for every chip. And then we need to switch the HyperRAM controller into runtime mode, where it will run data. Run requests from the cache controller, basically. Is that clear? Maybe I've lost everyone. If that's the case, just tell me. I'll try to explain better, but that's the general idea. That's basically what this method is doing, right? The first thing we do is we're gonna need this wait idle method. Honestly, don't remember what it does. Okay, that's not too complicated. Yeah, I know. HyperRAM wait idle. Okay. Wow, I haven't written RISC-V assembly in a few days, which means I forgot everything I knew about it. Okay, so we need to implement this. Bad news is, of course, yeah. Okay. Load. I just need to think about which register I'm using here. HRAM. You know what? I'm just gonna consider that A0 always contains HRAM base. This way I can just do all my access. Load word 0, A0. No, not 0. HRAM CSR. Load word into T0. Okay. And T0. No, and T0 with HashRAM header config. CSR header config. So that bits needs to be 1. So if we have T0 which is equal to 0, we can jump back to this. Looks correct. Any assembly expert in the room? I'm actually gonna leave that as comment because why is everything commented? Like, there be some. Okay, the highlighting sucks. I don't know why everything is. I wonder if I have RISC-V highlight, because I know it's better highlighted on my laptop, but I'm wondering if I installed a special plugins for. Oh yeah, actually I installed some bundle on my laptop. That's probably why it's better highlighted there. Okay. I don't think I have that set up here. You know, there is nothing set up here. Okay, never mind. That will have to do. So move We need to save the return address basically, right? I'm gonna use x30. Is x31 something special? I need the register names. Yeah, okay, but that doesn't help me. Okay, this file. I want to know like the caller saved, callee saved. Okay, that's okay. Return address is x1 usually, so I can use. I'm gonna use T6 to save the return address. Return address, and then here I can do jump. What is return like the? Okay, never mind. I'm just gonna do move. I know you can just directly jump to T6, but I don't remember which instruction is. Okay. I am going to. We don't need the code. So basically, gonna copy that. And progressively re-implement it in assembly. I mean, it's mostly just written a few things through a few registers, so it's really not a big deal. Although here we definitely want something else. iCE40 playground, project, memtest, software. I think I'm using the other edge by default. Yeah, I'm using edge 1 by default. That's what I wanted to see, is because that's the parameter which is not like in the result that I printed here, that's not something that's written down. Okay, so load immediate P0 HRAM reset. Forward P0 to HRAM CSR P0. Call probably a little more space here. Then set it back to 0. We already have 0 here. Bark? What do you mean? Oh, okay. This calls a sub method like HRAM write. So first I need to compute what is this. Like what is this thing? The value of this. And then I'm gonna need to implement HRAM read write. So I'll do that later. I'll just do the controller config here. Load word T0. Do I need this for edge? We're using 1. 5 phase. We have phase 1. Delay 7. Capture latency is 4. Command latency is 2. That's all the controller parameters, by the way. And we set that to the CSR. Oh, I'm missing a comma. Okay, let me check that. Yes, good catch. Wow, somebody's paying attention. Okay, so the only thing we needed, this sets up the controller. Okay, except this is not what I... and then or E T0 just run and then store it again. I think that should be good. So we only need to this method HRAM regulate, which hopefully is not too complicated. I think it's just writing stuff in the command queue, right? Yes. I mean, it's annoying, but it's not the end of the world. Okay, it ends with a wait idle, which means what I'm gonna do is basically make it before wait idle and just share the tail. Oh wait, that's mem write. I want read write. Yeah, this thing. Which is actually simpler. Nice. Okay, use HRAM everywhere, so I'm gonna do this. Okay, damn it. For a minute. Yeah, I think here I set that up to minutes. Okay. Wait it up, HRAM read write. Let me catch up on chat. Yeah, there are voices outside, and I do indeed have the noise filter set up. I did reset up a few audio things before the stream, and I didn't get a chance to test the quality of the result. But yeah. Wait, did I? There's no. Okay. Nice. Okay, so what does HRAM? Oh wait, A0 is argument 0. It's not address 0. I'm an idiot. What is the latest? What is the last? Uh, A7. Okay, I'm gonna use A7 instead of A0. For this thing. Okay. Ashram writes. So A0 is gonna be chip select. A1 is gonna be the address. Yeah, the address and then the value. Okay. Did I define this something somewhere? No, okay, so what is this? Other X CR0. And then we need to compute this thing basically. W what? Ashram CR0 base. Oh. Okay, so it starts with a default value of A80F0. Okay. A0. Okay, so that's the default value. Then we set the latency to CR0 latency 3. Latency 3. 1110 for bit 74. So that's E. Okay, so it's set to F by default. We want it to put it at E. Right? 3 clock latency. Okay, so that's what this does. Fixed latency is 1, hybrid burst is 1. Fixed latency enable, bit 3, set to 1. So that's 8. Okay, so this what this does. Hybrid burst equal 1. Hybrid burst equal 1. Honestly, it doesn't matter because we don't actually do consecutive burst, but whatever. That makes it C. And burst length is burst length of 128. 128 bytes is 0, so that's what we have. Okay. So that's the value of the CR0 registers. Next, we need to call this thing. Honestly, I mean, I could do a loop, right? But I think it's gonna take less instruction to just do this than actually do a loop. So now I just need to effectively read write. Yeah. Okay. Okay. Honestly, I was hoping kind of that this part would go a little bit faster, but yeah, things always takes longer than I think they will. Did that sentence make sense? Make sense? Okay. Oh, man, CA. What is HyperRAM CA? CA to DW1. DW regval address. Okay, what the hell? DW1, DW. Okay, I think I just need to read the damn data sheet to know what the hell I'm supposed to do here. Because honestly, that code is. I mean, obviously, I need to write a couple of things to a couple of registers, but I don't know like that value and that value what they're supposed to be basically. I mean, that's fairly clear. T0 X30 and forward T0 to HyperRAM WQ ATTR A7. That part is easy, okay. And then we have 3 independent stores to WQ data because we need to write apparently 3 data words. Data. And then we actually need to submit the command, which is load immediate T0. Oh wait, CMD CS. Of course I can't do. Yeah. CMD CS. It's shifted by 2. Okay. So I need to. What's the shift instruction in a shift? Logical right? Is that the shift instruction in a? Yeah. SRLI. Okay. I was missing the immediate because I want to SRLI shift right logical. Yeah, okay. What I'm gonna do is A0 is CS, and I want to shift it by 2, and then I'm gonna do or I T0, T0. And then I want to do this to WQ CMD. CMD. Okay, so visitor is just 0. That's fine. Now I just need to figure out how the fuck, what the fuck is CA? I think, yeah, okay, I remember. It's the command, CA is command address, right? That's what it stands for. And I need to find the format for this thing. Command address, command address, command address. Okay. Identifies. Okay, but that's. I want the command address for register write. Command. Okay, yeah, great. Command address. Yeah, great. I want to know where the fuck. Write transaction result. Okay. Yeah. Okay. That doesn't help me at all. Okay, is it the same? Rust MSB. Okay, this thing is just a mess. Break valve. That's not the right thing. Oh yeah, that's just wonderful. Like the LSB and the MSB of the address are not even contiguous. Like what the hell? Um, well, I can't mix C structure. Like the thing that I just that I cut and pasted here was just until I translated to assembly. So so this thing will definitely not build. Like I'm just trying to translate it right now into assembly. I might actually have an easier time reading the Python part actually. Okay, yeah, that's actually more readable. Okay, it's actually interesting that I'm writing to something called WQ1 instead of. Oh yeah, that's the attribute. Okay, never mind. Okay, no, that's actually not more readable. That's because. Oh, but I need to write it 16-bit at a time. Oh yeah, of course, yeah. That's because I send the commands. I don't. Okay, I write 32 bits, but only 16 bits are used. It's because the interface is 8-bit DDR, which is 16-bit at a time. Yeah. I would love an assembler where I can use C structure to like access things. That'd be nice. Inline C, yeah, that'd be nice. So I need this thing basically. I think it might actually be easier for me to just execute the Python and see what the hell I need to write rather than trying to re-implement this thing, probably. Feels like I need RW. Okay, so let me just get a shot. So that's what I need to implement, right? And that's gonna give me 16 bits. Okay. What? Oh, still I'm not looking for the right thing. Okay, so I'm just gonna execute that in a shell basically to try to figure out the value that I need to write because that's really not the point here. So yeah, here, and then I want CA. The register that I want to write is this one. RWN is 0 and reg. Yeah, this basically. That seems very long. Is that like what the hell? Actually, I'm getting a little lost in this code. Sorry if I'm not talking. It's because I'm trying to focus into what I'm doing. I'm trying to figure out just what the hell register I'm supposed to write at which place. Because I want the CA is shifted by 16. CA A0XFF. Okay, no, never mind. That's correct. 1, 2, 3, 4. So it's writing this in 1, 2, 3, 4, 5, 6, 7, 8, and then this and the value. Okay, so it's not gonna be a generic read write function. It's just gonna be HyperRAM set the C as 0. And so this is going to be hard-coded, and this is going to be hard-coded as well, because I don't have... and so here, I'm going to have T0, and this is going to be 1, 2, 3, 4. And T0, and this is going to be 0x. This is good. That should work. Of course, I'm saying that, and it's gonna fail miserably. And yeah. I'm pretty. Wait, you can use expressions, right? Can't you use expressions? I'm pretty sure I used expressions before. You need to hash with dollar for the expression to work. That doesn't work. Oh. Yeah, never mind. It's because I'm an idiot. Load word T0. I probably need parentheses or something for it. No? Why? You didn't get a parent. Load word. Oh yeah, it's because it should be load immediate and not load word. Okay, it built. It doesn't work, but I mean, it didn't build, but yeah, never mind. Wait, it'll. Hash RAM, you know. Procreation truncated to fit. Huh? What? What do you mean? Anyone else got a clue? It'd be nice if you gave me a symbol or something, not this. And usually location truncated to fit mean that you have a. Yeah, but that doesn't make sense. What? Oh yeah, against undefined. Yeah, great. That's just that for. Oh, that's the same thing, right? This is just an alias. Yeah. Is this one? No. That's not helping. What? Oh, is it the jump to this? Like, is it too far away or something? I mean, it should be able to. Okay, yeah, that's it. Why the hell? Okay. Um, how do I do a long jump then, or a jump to register? RISC-V instruction set. That's the coding convention. Okay, on the jump. Jump and link. I want the jump to like register. GAL no. This like a cheat sheet. Yeah, cheat sheet. with everything on one PDF, which is fairly nice. Okay, that's not bad. Upper image instruction, into a jump instruction. Okay, so it's GALR. Okay, let's call that GLR then. LE A0 GLR 0 A0. Oh, that's it. Oh, that's it. Illegal. Okay, that built. I just want to go if it still prints C. Or if it does anything vaguely correct or whatever. Oh, Dimitri, I didn't know that I've just read your comment on ISC. I didn't know that you were the one with that nickname. Okay, so it did build and it compiled. And it prints A and B and not C, which means it crashes at some point somewhere. Interestingly, it actually gets to here. Huh, okay. So the HyperRAM initialization finishes. It just crashes. Outstanding. I'm just trying to figure out what the next steps are. I was kind of hoping to have like a C environment to debug the HyperRAM access, but obviously I completely forgot that I don't have any RAM. So there is So I mean, here obviously, in case you didn't catch that, it's going here, so it goes through the initialization setup, so it doesn't crash there, but at the same time, this just writes some register, it doesn't actually check anything. It does wait for error, so at least that part isn't crashing, but that's pretty much the only checks that are done internally. And it crashed between B and C, which means it crashes in the SPI flash read. Probably doesn't crash in the read itself. What it crashes is when it tries to write the data it read from SPI to the HyperRAM. It will do HyperRAM access, and obviously those access will crash. I am kind of surprised that it crashes because even if you script completely the initialization of the HyperRAM and stuff like that, and it's not actually talking to the memory, the controller will respond. I mean, it will. It should, as long as it is, as long as long as it is in runtime mode. Okay. No, I got through there. Do I? At some point, I had a. Okay, no, I don't have it here. At some point, I implement like a print X routine, so I could print on the console some debug X stuff here. So let's go through what it does. Save the return address. That's good. It sets up all the access for HRAM base into A7. So HRAM base is set to A. Yeah, that's correct. We set the CSR reset bit. We store it in the CSR. We wait for the thing to be idle. How do we wait for it to be idle? We load the value from the CSR. We end with the idle bit, and if it's equal to 0, we jump back there and retry, which is exactly what this was doing. When we're done, we return. Okay. We set HRAM CSR to 0 again, clear the reset, and we wait for it to be idle again. We set the chip config by calling HRAM set 0, and HRAM set 0 calls this several times, 3 times with incrementing A0. Okay, so okay, we're not using A0, so A0 keeps its value. That's good. A7 is already initialized. And if we compare that with what this thing does, we write the attribute, we write 3 data, and then we write the command, and then we wait idle. We write the attribute 0x30. We write the 3 commands. This, the first one, second one, third one, and we write the command. Into HRAM command. And the command is, yeah, the second register, and then we have data and address, all 32 bits, all contiguous. Are these correct? 0, 4, 8, 12. I mean, it's not impossible, but I don't think so, because it did previously it did go to C when I was writing to some other place in memory that doesn't have anything mapped to it, which means that the SPI access probably works. My guess is the CPU is just crashing because of bad access, basically. We call this 3 times, and we can call it 3 times because we call it 4 times, sorry. And call should work because we don't override the return address in this method, and we fall through to wait idle, which uses T0. We don't care about T0 anymore, and we use A7, which is still set up, and okay, so that works. And then we load the configuration in there, write it. We add the HRAM CSR run bits, and we write it again, and we're done. We jump back to the address that we saved here. Missing ret? Where? This specifically falls through because after we set the CR0, we need to wait for idle. So I'm not gonna make a call to the function that's just right after. I'm just calling through. Am I missing? Was that function not super? Maybe that function is meant to be called some other way. I mean, it's called HRAM init, and that's the only method that really does anything. Yeah, that's the only function that's published, so there's really nothing else to do. So it does. Okay. Let's check. Let's actually check our hardware. Like the maybe I screwed up something when wiring up the controller. Right. That's definitely an option here. I mean, the address mapping is not correct, but at the moment I'm not worried about that because I don't care. Um, the cache configuration I haven't modified, so that should work fine. The clock setup is copied from the main test, should work fine. And anyway, the sock is booted. It's executing code. So we're good there. The address is limited to 24 bits, but that doesn't matter. Oh, wait. Okay. Because here I'm accessing some bits which are not defined, and if I'm accessing bits that are not defined, users might find them undefined and just optimize things away and do things that I don't like. So that might be an issue here. So I might need to actually set up the address correctly first. So I have the address. That I have here is 24 bits. So it was set up as 24 bits address space because I had 60. I had a 128 megabits flash. Why did I set it up as? I had twice that in the address space. So that means I have 32 megabytes. Why did I set it up as 24? In the I think I might have picked that arbitrarily because it doesn't actually need to be 24 megabytes. A 24-bit address is 16 megabyte. I mean 16 meg address space, but it's 4 bytes, which means that I'm mapping 64 megabyte, which is twice as much memory as I have. But anyway, we can keep it at 24 byte. That's good enough. I just don't remember why I mapped it that way. If I look at the RISC-V Doom, do I? I want the linker script that I used for this. Like what? Where's my linker script? Linker script here. Okay. So the PSRAM is okay. It's mapped here, which is at an offset of 0x1, which is 16 megabyte. Why is that? Wait. Risk 5 Doom. What here? Oh yeah, no, okay, I remember. It's because the this somehow always takes 2 bits for chip select, and so it was actually the QSPI master was configured for to have 4 chip select, and the SPI flash 16 megabytes, so we need each space for chip select to be 16 megabyte, which is why I had a mapping address space of 64 megabyte, but I'm not actually using 64 megabyte, I'm only using 32 megabytes. But no, at least I explain why it was 24 megabyte. I'm gonna keep it 24 bits. I will reduce it once I get it running. I basically want to change as little as possible, but I need the chip select basically to be each chip we have is 64 megabits, which means that 8, which means that 22, 23. Okay, so that would be 23, 22. I think, no, 22, 21. And then here we basically map 20, and so we have 21 bits. Of word address per chip. Yes, that's correct. But the address that we give to the controller must be 32 bits, which means so we have 22, so we need 10 bits here. Okay. Okay, so that's basically just details about we take the address that is provided by the VEX5 requests, how it goes through the cache controller. Like we don't use the full 32-bit address because when we need to store which tag lines and which tag address we have, it's sort of wasteful to map the full 32 bits. So here I've reduced it to 24, sorry, which allows me a 64 megabyte address space. And then I need to take those 24 bits of word address, of 32 bits word address, and map it to the address that I will actually send to the HyperRAM. And that's what I was doing here. Okay, so it still prints AB, so it didn't actually fix anything, but yeah. Let's actually check the use this report. Also make sure there's no warning that are worrying or anything like that. Placing memory, that's not a user only support. Yeah, that's not a problem. Yeah, that's not a problem either. Yeah, that's fine. Yeah, that's fine. Yes, it is. Okay, that's more worrying. Because the cache definitely needs those two signals. And that could definitely explain the problem. I think what's happening is that those signals exist, but the memory test wasn't using them. And so when I cut and pasted the code from the memory test, use these warnings are useful. So, wanna take some bets? Anyone? Hey, look at that! It's printing ABC and it's rebooting. Okay, I have no idea why it's rebooting, but it's doing something. Nice. Okay. Why is it rebooting? That's a great question. Why is it rebooting? I mean, honestly, I've because currently it's loading some code from Flash and jumping to it, and I have no idea what's in Flash, which means that that could be a perfectly valid response to whatever is there. But yeah, anyway, let's try to actually put something in Flash now. And so for that, we're just gonna create. You know what? I've got a skeleton somewhere. I'm gonna copy it from my laptop. It's for a completely different project, but it doesn't do anything at the moment. So okay. It builds. I need to remove everything that's in it because it's for completely different hardware, but it should boot. Basically, yeah, that doesn't exist. But we have a console and we have that kind of stuff, so I can remove that. Yeah. Console init, booting app image, blah blah blah. Okay, I need to edit the config.h is kind of the equivalent of the file that's generated by LightX. It contains what's where basically. Is it the mapping that I have? Why do I have the LED? Yeah, LED R3. Okay. SPI base. So we go to here. Okay, well, it's not doing much. What? Do I have a boot debug here? I do. Boot debug 81. So 81 is correct. I want to define boot debug. So it's this kind of a second stage boot. It's that at this point you're in HyperRAM, right? That's why instead of printing ABC, I'm printing 1, 2, 3. I'm running at 15 megahertz, so 13. Make clean, make frog. Okay, so the other thing I need to make sure is because here I flash this at 0xa00. I need to make sure that my yeah, see, I'm flashing this at 1 megab. So I'm loading the bitstream at a different address that I'm flashing it, which obviously isn't gonna work. So I'm gonna modify this to jump to 640. Aha! First, it's not rebooting anymore. Second, it printed 1, 2, 3. So it's doing something. It's actually executing some code from. Well, I mean, I'm not gonna say it's executing it from HyperRAM because at the moment, even if the HyperRAM was completely failing, it would probably still work because it's basically loading code into the cache and not trying to read it back yet because we're using so little RAM that everything fits in cache. Right? But it's doing something. The question now is why. Okay, I probably know why. It's because my linker script is completely has like absolutely no relation to reality. Like it's the RAM is not at all at this address at all whatsoever. So I need a different linker script. I am going to use the linker script that I have for Doom. Yeah, go with that actually. Yeah, let's do this because I mean the sock is derived from Doom, so might as well. Link app yes. Okay. We don't have 8 megabyte of RAM. We have 32. Okay, we definitely don't have 1 megabyte of ROM either. We don't have any ROM. We only have HRAM. Oh, but you know what? I don't. What I'm wondering is if I put everything in one section, it's gonna initialize that section, including BSS, right? I don't know if you can tell him to only initialize part of section. I mean, anyway, it's not relevant for now, because anyway, even if we initialize BSS, it doesn't matter. We have so little things in this test program that it really doesn't matter. I am just going to define this as being 32 megabyte. Should be 16, 32. Okay, so that didn't work better. That's disappointing. You know what? We're changing the UARTs. Actually, that's not the only problem, but that's one problem. No, that's not better. Okay, what could be failing now? I want to get to a point where I can execute something in C, because then I can test the HyperRAM is actually working. Just run a kind of mem test or something, and then we can change the CPU to a Linux capable variant of the VEX. Given the time that this is taking, I don't think we'll have the time to actually try running Linux. But at least once we've got the VEX variant with everything enabled, built-in hardware, that would be the hardware part done, and then we can move on to actually building Linux, probably in a subsequent stream. Why isn't it executing from C? What do you need to run C? You need a stack? Yeah, you need a stack, which is not set up. Okay, that's because the start program that I'm using here is designed for the PyQuery. Okay, the problem is this other one doesn't have any debug in it, so I'm gonna have to cut and paste some debug. For Doom, I kind of simplified it. Wait, do I set up? Yeah, I do set up SP here, but I don't set up. I'm just gonna set up realme 2. Just want something just before calling this. Yeah. Look at that. We're executing stuff. Oh. So now we can start testing memory. I did write some vaguely comprehensive might be a But I did write a mem test for the Pi5 sock, which I should be able to just cut and paste in here. So I'm just gonna copy that code from my laptop to. So where is that project? Project fpga exec Pi5. Nope, it's with Python. Where did I put that sock? P5. Firmware app. Okay. Okay. Oops. I mean, honestly, like this should be. Okay, I'm just gonna copy both. They kind of both memory tests, which stress different things. They try to do random access to like they completely trash the cache, right? Because they try to generate a lot of actual access, but 4.1. So I'm gonna start here. I can stop at 4.2.0. This should be 32 megabyte, right? Yes. Eep start. Okay. I just need start here then. So I'm starting like 1 megabyte into it. That's enough. Like, just want to make sure I'm not overwriting the C program I'm currently running. Okay. Well, that's not doing much. Oh, wait, never mind. It's just super slow. Okay. So it's... So interesting, all the errors seems to start at 408, which is the second chip. Right? Because it started at 401. If I stop at 408, would it succeed? See, it's not throwing errors now. Yet. Okay, so the memory test works for the first chip, but not for the other. Two options. We screwed up the initialization of the other chips. You know, we need to write the configuration register to several of them. Or we screwed up the memory mapping. Honestly, both are kind of equally probable. So let's just check both of them, right? And see what the hell did we screw up. Actually, let me go. Oh, wait, actually, I can get make here actually. Okay. Let's check what we do for this. We call HyperRAM set 0 and we increment A0 each time by 1, starting at 0. Oh, is A0 used? I call SRI and shift it by 2, and then I write it in HRAM CMD. Whereas, oh wait, that was it. Firmware support. HRAM CMD CS. Okay, yeah. This is left, not right. Okay, like left, right. Of course, yeah. For the camera, that is okay. Never mind. Anyway, it's shift left. Firmware app. Let's see. I can restore my memory test to test the 4 chips. 20. And it's still rebuilding the image, but I can already reflash the firmware, right? Oh yeah, it's. I mean, yeah. Being able to find problems is first. I'm very familiar with that code, with that what needs to be done and kind of stuff because I wrote most of it. And a lot of the problems I've had before, right? Like the fact that the stack pointer wasn't initialized. Like I know what's needed for the C runtime to work, and so I know that I screwed up the stack pointer before, and that prevented that from working. So it's kind of just experience at that point. Okay, running the mem test takes forever, but it works. And now it's testing the entire range. I mean, it does test it sequentially, but it still completely overwrites the cache, probably just because 32 megabyte. Yeah, I mean, the cache is okay. It still doesn't work. Huh. It's always annoying when you find that bug which absolutely perfectly explains your issue. You fix it, and your issue is still there. That's it's just man. Damn it, that would have been so perfect. Like that example here. Sometimes you have a good guess, you fix it, and it fixes absolutely nothing. You know what? Huh. Look at that. 1135 boot.x 2251. Okay. Try again. Something in my makefile isn't detecting the fact that if I change boot.s, it actually should reboot boot.x. But yeah, that's kind of annoying. Wow, I just noticed on the webcam that my lighting is absolutely terrible. Like my face is basically dark. Um, Give me a second. I have one of those fancy portable LED panel thingy. So I wonder if I can use that as a quick lights. Okay, Jesus fucking Christ. That's much better, right? Okay, that's still way too bright. How does this thing work? Okay, like this. Probably be put on the side of the camera. Well, okay. It's slightly better lit at least now. It's not perfect because it's way too harsh, but I don't have a diffuser for it, so yeah. It's also oh man, it's a little harsh to look at. I mean, this thing is dim to like 10% at the moment. Yeah, that's better. Okay, so it rebuilds. Starting the memory test. Fingers crossed. Come on. Whenever you want, guy. Just. Hey, look at that. Passed man test. Perfect. One iteration, that's really all you need to test all your memory, right? Okay, so now we can finally get to the interesting part and see. I mean, the stream might end very soon if when I generate the Linux configuration for the VEX, if it doesn't fit, like by a huge margin, that might end the op directly. Actually, what's my current resource usage here? I mean, this vex is not minimal because we have one cycle multiply currently enabled, which we definitely don't need for this. Where's the report from? Yeah, because currently we're using like 85% of the UP5K, right? So I need to fit an MMU in like 600 slice. What do you think my chances are of that? But I can remove some stuff from the vex because I have like single cycle shift, single cycle multiply, and stuff like that, which were done for performance for Doom, which I don't care about here. Like if you're running Linux on an iCE40, you've given up on performance already, right? This is not about. So I'm gonna keep a copy of that vex configuration here, and I'm gonna generate a new one. Okay. CD data vex, I think. Okay. So, okay, that's the diff that I had applied for Doom. Okay, that's the command line to generate the vex. And this is what I need to edit to change the vex configuration. Wait, what? Do I have that open somewhere else? I don't think I do. Okay, yeah, I did. Okay. Debug force iCache. We don't really need much RAM, so we can put 248. Muldiv force, yeah, definitely. Single cycle multiply, yeah. Single cycle shift. You know what? I'm just gonna leave it at true, and we'll see if I need to remove it or not. The main thing we need to change is this. We need to put Linux. So there's two variants. There's Linux and Linux minimal. We're definitely going to go with Linux minimal. That was to enable compressed instruction. We definitely don't want that. We might try to move branch prediction to none if we want to do something smaller. Let me see what we have for Linux. TLB size, blah, blah, blah. Whatever. Oh, wait. There was something here. Yeah, okay. So that's something we need to change. So this thing, this defines basically for the MMU which zone are IO and which one are memory. This whole equation thingy is for the Lytix configuration. That's because that's where Lytix maps its stuff and stuff like that. I have none of this. I just use the MSB to know if it's IO or not. So I'm just gonna simplify that to this and be done with it. Okay, so let's try to build that. And copy that to here. Wait, no. and see just how screwed we are from a resource point of view. Oh my god, this is... Let's go. Oh, make program. I'm kind of optimistic here because... No, this probably won't fit, right? I'm gonna have to strip more stuff. Any bets on how many LUTs I'm gonna have to remove? Oh wait, look at that. Yeah. Oh, come on! Are you kidding me? Okay, well, I need to strip some stuff, but we're not that far off. I mean, realistically, we're gonna need some room because there is no way the placer is gonna be able to place that at 100% usage, right? But we're not completely screwed. Let's give up branch prediction. Who needs that anyway? Are we? Oh, where are we on the number of RAM? Ah, we're good. Okay. Let's try that. Oh, we can also try, because I think I have ABC9 enabled. ABC9 tends to produce slightly larger logic than the old one. So, hey, look at that! It fits. What? It found a valid placement? Well, that was easier than I thought. Okay. Never mind, then I can't really scroll back because it always scrolls back down while it's moving, but I want to see what kind of usage we have at the moment. Yes, I have. No, at the moment I don't have single cycle multiply enabled. I had it for the Doom one. I disabled it here. I just reverted to my basic configuration. I do, however, have single cycle shift enabled, which means that if I needed some more space, I could disable that. But I somewhat suspect that shifts are used quite heavily. I mean, multiply as well, but you can't have everything, right? You know, once I have something that runs and boots, we can try to optimize it, but here I'm just trying to get something that fits and roots. You can see that the next PNR is definitely having some trouble rooting that, right? It might be a nice 40 with only 5,000 LUTs, but when we ask it to fill it to the brim, just a tiny bit congested. I mean, it's going down. That's the number of remaining arcs, by the way. So it needs to go down to 0 for that to. I don't actually know if next PNR can give up routing. Like if it has the maximum number of iteration or something like that. I don't even know. You have bricked the router before? Yeah. Okay. I mean, I know on the iCE40. I mean, from what I remember that GateCat told me, is that the iCE40 is very well connected. Like it has a lot of interconnects compared to something like a Xilinx 7 series and stuff like that. It's because apparently Xilinx has more confidence in their tool to be able to find routes and place things more intelligently and use less routing resources. On the iCE40, they kind of went a little bit overboard on the routing resources, so they don't have to be as smart, basically. Wow, this is taking forever. Come on, you can do it. Eventually. Maybe. Anytime now. Yes, the the vex is written in Scala in Chisel, which is Scala basically, and so you can it's both basically. Yeah, I mean there is some forward progress, but really not much. And so yeah, for the vex in the Scala, you have both the RTL described in Scala, Chisel, and the configuration of the core also in the same language, basically, kind of like in NMyGen, where you both describe the actual hardware and RTL in Python, but also configure the option of the core and stuff like that using the normal Python parts. Yes, exactly. Oh yeah, it's sorry. Wait, is it Chisel or is it Spinal HGL? Is it different? I Chisel is something else? No. What is Spinal HDL versus Chisel? Okay, Spinal HDL is a re-implementation and improvement of Chisel. Okay, so I wasn't completely wrong, but okay, like what the hell? I want to see how many LCs I used. Yeah, maybe it's in the log already. Do I have the PNR report? Yeah. How many? Okay, so yeah, we have like 112 LC free. That's something. This literally has been running PNR for 6 minutes. Yeah, I've never got to hours, but yeah, I've definitely had some pretty long ones. Hopefully, I mean, yeah. If it gives up, I'll just remove. I'll just try ABC. No, not ABC9, the other, the normal one, to generate smaller logic. I can give up single cycle shift to. No, it's not multi-threaded. And the CPU is a Ryzen 3700X. I mean, it's making progress. It's just okay. Never mind. Just as I say, it's making progress. It goes back to 1733. Yeah, it's only using like one core. Like this is just yeah. Only it's apparently not easy to parallelize. Yeah, you guys have any questions or anybody? I'm not very sure how to fill the waiting time. To be honest, come on, just finish already. No, yeah, it's not giving up. It's slow and steady, but no, still slow. Well, no, two reasons, Luke. First, I don't have an HX8K. I don't have any. Secondly, the UP5K has those large SPRAMs, right? So I've got an internal 1 megabits of SRAM that I can use as cache. The HX8K doesn't have that, unfortunately. Actually, it's not true. I do have an HX1K. I have a Glasgow, so technically I do have one. I mean, technically I could have tried to boot Linux on the Glasgow using the dual HyperRAM. Now that I think about it. But I only wait. What are the chips that are mounted on it? I don't remember what I mount. I don't remember if I mounted 128 megabits chips on that. Let me actually check that. They have oh well, that's just perfect. Anyway, that's a Glasgow. You've seen it before, like pretty much. I'm sure everybody has seen it before. And that's the HyperRAM module add-on for it that Esden has done on stream. I've got a prototype here. I don't remember which. And I got that HyperRAM controller running on it recently. I just don't remember which chips I've assembled on it. I don't remember if I put 128 megabits chips or 64 megabits chip. And my eyes are just not good enough to read the part number. Seven KS 128. So I did put 128 megabits chips on that thing. So technically, I would have 32 megabyte of RAM on an HX8K. So yeah, that might be a Linux capable Glasgow. Why would you want to do that? Well, I mean, obviously, I have no idea, but I think at this point we're past asking why. Right? Come on! Oh, come on! It's almost there, like 552. The next question, of course, is what kind of timing we're gonna get. We 11. Come on, you can do it. Yes, yes, it does. That's why I'm heavily questioning the results we're gonna get. But honestly, if we're anywhere close, I'm gonna call it good enough, and hopefully the chip will be fast enough. Like if we're above 15 meg, if we're above 10 megahertz, it's gonna run at 15. Like that's gonna be fine. I'll just bridge the. Oh, thank you for the follow, Fritzlang. Yeah, I need to find better gifts. These are just the default one from Streamlabs. Yeah, one warning. Yeah, I didn't pass timing. What a surprise. Oh, you know, like it meets like 12.52. Yeah, it's gonna work at 15 megas. Like I'm not gonna try further. Like that's fine. The question is, does that vex even work as a normal vex? Like when you have the MMU configured? Apparently, yes. Oh, okay. We might have to strip out the single cycle multiply because I just realized we're missing something. We don't have a timer. I'm pretty sure Linux needs a timer interrupt. We should be able to get some things running without it. So I might defer. Yeah, at the moment, as far as peripherals, we have the HyperRAM controller, which you can't touch because it's when it's in runtime mode and serving RAM, you can't configure it. We have an SPI controller, so we can access Flash if we need to. We do have a UART, and we have a RGB LED controller. So yeah, that's kind of my hope, is that we should get some early printf before the timer interrupt is required. If we Once I get to that point, I can add the timer. I can win back some logic. Actually, now that I have that bitstream, let me actually save the this, and I want to try without ABC9 and with yeah. What? To see what the size difference is. But at least no, we should have like a nearly Linux capable thing, so we can try to move on and to booting Linux. Okay, how does booting Linux even works? Um, okay, just let me. Yeah, I should have just paused it, not killed it. I just want to see the resource usage. Yeah, see the resource usage is slightly lower here. So it's still running its mem check. Okay. I'm gonna okay keep this. We don't need this anymore. Okay, so I'm gonna move. Okay. So for now, I'm gonna call the output good. Do you have something that commits your progress automatically? Nope. No, I don't have any commits. I know I don't have a. No. I mean, I could. I mean, I know not automatically, but I could commit if I wanted to. Like, okay. What do I have here? Because it's pretty much so this. I mean, the okay. I'm gonna update the README because it's obviously not correct. Mm, yeah, we want this. Yeah. Also, this. Okay, I probably want Yes, yeah, yep. So good, yeah. Wait, no. I don't want anything from sim, I don't want anything from software. There, it's committed. Okay, so it seems to be slightly faster, but not a whole lot. Anyway, we have a version that's flash booted, and so we can move on to the Linux part of things. Data, FPGA, stream, and move on to Linux. Okay. I can kill this, I don't need it. So in build root, it builds some stuff, right? Little disclaimer, I haven't used build root in like 15 years, so I have no idea how the fuck this thing works. I literally just went here and typed this. I did, well, it didn't actually work. Like if I go to, actually I had to apply a patch for it to work because apparently the build root was updated since the last time Lytix Vex Risk 5, since Linux on Lytix has been updated last, and so they've moved on to kernel 5.13, and so I had to force it to use 5.12. Okay, build root. So anyone familiar with the boot process? Okay. So it produces images. I think the image actually includes the rootfs inside of it. Oh, I don't have. Let me install binwalk. Uh, blah blah blah. The zip compressor data. Okay, CPI archive. So yes, my guess is the image is actually included, which is good because that means I only have one 7 MB flash to one. Ideally, I should just be able to flash that, and it should work. Yeah. I know it's a configuration option because I use that on my laptop. I just didn't know if that's something Buildroot did or not. But it does, which is good. Because ideally, like I also want the default command line because I'm not gonna be passing any command line. Ideally, I just want to just jump to it, right? Which I think is what the BIOS does because the Lytix BIOS. If I go to the Lytix. From isn't in the chat by any chance, right? You never know, but where is the BIOS? the bias thing. Isn't there? Oh, it's here. Okay. Bias. Okay. Um, like there's nothing Linux specific in there. Like the Linux BIOS doesn't know especially how to pass argument to a kernel or anything like that. I think it just loads something and jumps to it, as far as I know. Boot sequence. Yeah, the boot sequence, net boot. So like serial boot is usually what's used. And if we go to, is there like a serial thing? Boot. Okay, so that's actually interesting. Oh wait, no, never mind, because that's for a completely different CPU type. Okay, never mind. So it receives the blah blah blah, and then what? Yeah, and then it just jumps to the address basically, right? Yeah. Boot 0000 address. And boot is this thing, which does it disables the interrupt, but I won't have them initialized. It pushes the thing, prints as boot, and yeah, okay, so yeah. There's nothing special about it. Yeah, I think here in the case of Lytx, there is no U-boot, there is no bootloader. It literally just loads the images and jumps to it, which honestly is kind of what I want here. I'm sure there's you know other options and stuff like that that you can do to pass argument to the kernel and stuff like that, but here I really don't care. I just want the simplest way to jump into the kernel and let it do its own initialization and stuff like that. Um, Several things I want to check. No. No. Okay, so that's where the birds. Okay. Okay. So that's I've just found where it basically built the kernel and just disassembled VM Linux. Um, First thing, it expects to be loaded at C000. That's wrong. We need to change that. That's not where our RAM is. So we need to find a way to change that. First problem. The good thing is apparently it has something at address 0, which is valid code, which is jump to start kernel. So that's nice. And that seems to contain valid code. Nice. Second problem. Uh, okay. The other problem is what variant of the CPU, like what ISA is it compiled for? Because I see there is like a fence here. Is that supported by the variant that we have? I have no clue. It might be, it might not be, honestly. I saw also some this AMO add. Is that like that's an atomic instruction, isn't it? AMO add description atomically. Yeah, okay. So does the Vex has atomic support? Um. Okay, and apparently it's been compiled. Okay, yeah, with a multiply and divide instruction. We don't have those. Okay, so we need to either. I think atomics are not. I think atomics are not optional. I think the Vex just always supports atomics. I'm wondering if we can check that somehow. Um, I mean, there's something related to atomic. Let me check the source code for the Vex. That's not good. Oh yeah, there's a bunch of things in the. Okay, so what kind of worries me here is that in the README, it says it supports AV32i, so that's correct. M is optional, compress is optional, and the A in brackets might mean it's optional. The question is, I didn't see any option in the Scala for that. Okay, I want to find the source code. The option that I used in come on, Vex in Litex. So there is a repository somewhere with the all the Scala option that basically is used to generate the Python. Is it? I don't think it's Python data. I think that's just a Verilog. Hmm. Wait, what am I? No, okay, that's not the repo I want to check. Python data, blah blah blah. No. CPU, PyCoV, Minerva. What is the specs? Not SMP one. Okay, this. If that's just the Verilog files. Like I want. Oh no, okay, never mind. There is the Scala source code, I think. Okay, so it looks like this is what I'm looking for. Make file, Vex, Linux. So the only thing it sets is the CSL plugin to Linux minimal, which means that we should. I'm guessing that by default the multiply variant is enabled in there. Assuming that muldiv, yeah, muldiv is true by default. Oh wait, there is an atomics false. Oh, okay, that doesn't bode well. Okay, so it sets with LRSC. With LRSC, okay. Okay, if that option isn't already enabled in no variant, that's gonna be a problem because I'm not sure how much space there is left. Okay, so yeah, we don't have a separate option to enable atomics, but we already have the with LRSC Linux with LR. So the code that we generated actually has atomics. No, apparently it's something in the dbus access plugin, which has this option needs to be enabled apparently. I mean, we only have a single core, but we can still have still need atomics for interrupts, right? And so my guess is that it just considers it a single instruction and do a single. It's capable of disabling interrupt during the fetch and write back. Basically, we don't have memory reordering or anything like that. So yeah, but at least this configuration works for Linux. That's what's used in Linux in a LiteX. Which means that the configuration that we have should work. We, however, do not have multiply, but multiply should be optional. I don't fence is. I don't think it's an optional instrument. Fence is probably a knob on single core anyway. So we just need to disable multi. Okay. So we need to go from we basically currently are configured for a V32 EMA probably, and we need to go to a V32 IA. Okay, let me drink something because I'm talking a lot here. Let me open the source actually of this. No. Yeah. Wait, this is just okay. Oh wait, no, there are sources in it too. Yeah, there are C files here as well. Okay, anyone familiar with build root? Like where, if I want to edit the source that are being built, because the thing is here, one thing I've noticed is that there is this thing. Important though, the git tree located in this directory is for exclusive use by build root, which uses as a local cache to reduce bandwidth. Will trash any change in that tree whenever it needs to use it. Do not work in that directory. Okay. When you say do not work in that directory, I would really appreciate if you told me what the fuck to do instead and to achieve the same thing. Like where am I supposed to work? Like I want a directory with the Linux source that I can edit, modify, and do my changes, and that build root when I type my make image thing so that it builds, uses that and doesn't trash the changes. Anybody got a clue how to do that? Why don't I have a home page? Thanks. If you find something, that'd be nice. Okay, my monitor is telling me it's pouring off in 5 minutes to save energy. Wait, okay, great, but like why? Like I'm in front of it. I'm not even sure. I don't want to configure it. Okay. Okay, that doesn't have me at all. Okay, there's a build root. Okay, I'm just gonna. No, the result, the directory I was in. I mean, the one you're listing is the one where where things are built apparently. But I was in a data fpga. No, sorry, that's my local path. What the fuck am I doing? I was in a build root dl/linux like this. I mean, there is one like, but this is not a git, right? Oh, it is. Okay. So I can edit things here. And it won't override it. I'm less convinced about that, but Oh, gee, wonderful. Uh, okay. Okay. Okay, well, I guess we'll do it like that. Something I might try to do. So wait, what was the command line and you need to type? No. Okay. No. I think make Linux rebuild. No, I do not have the current working directory in my LD library. I just have an empty valid. I mean, technically, I don't need it because I don't need the FPGA tools in that particular window. But make Linux rebuild. Wait, but that doesn't help me. Like, I need to edit the source. That's kind of what I want to do. Because I'm gonna need to add drivers for my UART and stuff like that, right? And I want like a tree where I can work in and because the thing is typing make here doesn't work. Like if I do that, that doesn't work. Because it has none of the configuration that. Oh, okay. I see. Um, because okay, so when I do make Linux rebuild, it rebuilds that thing. Okay, and that works. Okay. Um, uh, okay. Yeah. I'm just setting up something to automatically every minute take a snapshot of the diff so that if by accident I get it overwritten. Did it create the diff? Yeah, okay, so except I wrote path instead of patch, but that's the same difference. Okay. Perfect. Okay, it's absolutely everywhere. That doesn't help me. I'm kind of surprised that git grep doesn't find v32. Because I would expect something to contain v32. Arch was 5. Yeah, I mean, okay. Isn't that file in Git or something? Where does that file come from? No, Dread, I was just making some space in my disk, and I was erasing a capture file or a debug file from SRSLT. Seriously, where does that file come from? What created it? Ah, it just appeared? Or what the hell? I'm sort of... What? Okay, so I think the Linux source tree that's used is somewhere here, right? It uses this. I'm pretty sure. I think that's the branch it uses. Arch. I mean, that file is definitely here. Oh, you know what? I think this isn't a Git repository. Yeah, the log that I'm seeing is not oh crap, I spammer now. The hell? How do you even ban people? Ban. Yeah, it's not actually a baseband capture, but yeah, it's just select burst, so it's not that large, but yeah, still whatever. Yeah, but the thing is, it's not the Git I'm seeing here is the Git from build root, right? Not Linux, basically. So that's not a Git repository, which means that my Git diff thing here is doing absolutely nothing, basically, because I can't diff. I can't diff that. Oh my god, that's why I hate these like fully automatic things like build root and stuff like that. Is because yeah, if you want to execute the exact thing the guy it's been designed to do, but I don't know if it's because there is a full Linux like here is a full tree, right? Build. Here there is a full Linux tree. That's the Linux tree. Yeah, and I'm finding something here. But if I change that, I think that's gonna do absolutely nothing. Like no, I ask it to rebuild this. Yeah, it's not actually rebuilding anything. Really? What the? I mean, like working on some package seems like a basic thing to do, right? You being able to edit the source, build it, test it. Like that's okay. I'm gonna check on IC. Oh, for fuck's sake, you need to be registered on OFTC to join that channel and verified. What the fuck? Okay, of course my nick is already registered, but I don't know if it's registered to me, or if it's registered to somebody else. Okay, apparently not. So, okay, can I? Okay, so apparently I do have. Sorry, I'm just trying to connect to the IC from build root to ask if. Oh wait, you have found something. I'm not entirely sure I understand what the hell it's talking about though. Uh, Okay. So, okay. One issue though is that the Linux tree is very, very big. Um, and I'm not sure I have enough space to have a second copy of it. There is a way to do a shallow clone without links. Git shallow clone mod link thing. Okay, let's try this. Git clone Linux iCEBreaker. Build root. Yeah. Linux. Git. Where's no this disk? Okay. Perfect. That's better than nothing. Okay, so here I have my source tree that I want to use instead, and so I need to override Linux. Okay. Linux override source dir. I'm assuming that's where this goes. Oh wait. Oh, next to the wait. Local.mk. Okay, never mind then. The default location file is as defined by beer. Wait, so the package override, the br2 package override file is set by default to this, or do I need to set it? Oh, okay. Oh yeah, okay. So it's set by default, so I don't need to change it. But so because like the build root configuration for Lytix has something here, so I can just set local.mk and so here there's gonna be Linux override associate equals / home tnc data. So that looks correct there. I don't know, I've set it next to the Lytix Vex RISC-V def config, which is the because like in the so in the Vex build instruction thingy, did I keep that open somewhere? It does set up make br2 external and then light this config file as config. So I've set it basically here. Oh wait, maybe it should be actually here next to external.mk. Okay, I have no idea what external.mk is. Okay, let's try this. So what if I do this? Does it do anything? I mean, definitely didn't rebuild anything. Can we see if it ran? Okay, let me modify the source. Right. Vim. Let's go this. I mean that. So build root is is here. So basically, I have build root, and then I have the Linux on Lytix Vex RISC-V, which contains a build root directory inside it that's pointed to is br2 external thing. Yes. Like in the where I type mig, basically there is a config thing. You think it needs to be here? Okay, that definitely did more things. So now what I'm hoping is that it's only rebuilding everything because it changed the tree. But I'm hoping that if I change one file, it's not rebuilding the entire thing every time, because this is gonna get old very, very fast. Okay, so it did take my source because it bugged out. Okay, but no, if I do this, it's not gonna rebuild everything, right? No, it only rebuilt what I changed. Awesome. Great. Thank you, Ati. Very, very good. Very good. Because now we can actually do something. Um, Outstanding. I most likely need to do. I doubt that it's gonna detect that change as a and rebuild everything. So I need to force. Yeah. I think it's. Oh, I think it's dear clean. I think it's dear clean because here I need to actually rebuild because changing a makefile architecture option is not gonna be detected. No, I don't think so. Usually, when you modify a compile option, like changing the optimization level or something like that, it does not rebuild. Anyway, here it rebuilt, and it's obviously failing because it's not finding. So I'm guessing basically libgcc isn't linked in. Um, okay. So, going to find a way to solve that. The other point was the start address that needs to be, which at the moment is okay. I was hoping for a little less hit than this. So okay, it's at least taking my option. Not the, but I want to change the base address first. To see where that is. Where would that be? Linux. No. Yeah, Linux build root output build Linux custom. Okay, so it's a config page offset. I need to find where config page offset is set. Okay. Huh. Okay. I mean, I would have expected to be set somewhere. Yeah. I mean, it's still gonna fail, but yeah, right. Sorry. I forgot that it's in the case. It was probably a default config, and yeah, got it. Thanks. Yeah, I thought it might be in the platform config, but in fact, it's not. It's just the default value for RISC-V, which triggers a full rebuild of absolutely everything. Okay, so the next problem is we need to link it libgcc to have the multiply and divide instruction provided by. Okay, well, Ati, yeah, thanks, definitely. Yeah, that was a big help. I probably won't be much longer because I've been streaming for how long here? Like 4 hours. I think I want to have a quick look at the if I can get libgcc to link. But yeah, it's getting late here too. It's like 1 a.m. So yeah, definitely. So I guess there will need to be a part two. But at least now I'm fairly confident that it should be possible. Like because when I started, I had no idea if it would even fit or not. But like the SoC, we have a Linux capable Vex variant loaded up, running. We have 32 megabyte of RAM. We have a UART. The only thing that we're missing is a timer. So we need a timer interrupt, which should definitely. I mean, we have we definitely don't have a lot of LC free, but we should have enough to put a timer and okay, yeah, we should have enough to put a timer, and possibly. I mean, if needed, we can still strip some things from the Vex to make some more RAM, to make some more space for and gain some more LUTs, like the single cycle shift we still have in there, or I mean the LED controller we can strip as well because I mean it's a hardware block, but it still uses some blocks for the hardware interface, stuff like that. So yeah, from a hardware standpoint, I'm feeling fairly confident that it should be possible to fit it. So another question is, yeah, can I get the actual Linux side of things? So yeah, I wanted to quickly check that. Okay, one thing that annoys me is that it uses its own toolchain. I would have much preferred if it used mine. Is there a way, root use? Like, can I just tell him to use the okay. Can I use an external toolchain? How do I do that? I don't want to build it with build root. I want to use build an external toolchain. No, I want to use an external toolchain. Wait, what am I looking at? Use a completely custom external tool. This is particularly for toolchain generated using. Okay, never mind. Select. in the tool chain list. Wait, what? How do I do that? Good night. Why I opened it? Oh, okay. I understand why it uses its own. But for the kernel, I would prefer. Oh yeah. Okay. I just thought that all the user space that has been built has probably been built for RB32 IM as well, which is completely invalid. Okay. Okay, user space, we'll worry about that later. So if I can just get the kernel to build with that. Because I'm not even sure that the toolchain that they built as libgcc built. Like if I look at Linux build root, output, host, then, okay. That's the toolchain that it's basically using. Right. I mean, it did build the libgcc here. Why didn't it allow to list? Okay, maybe I can just use strings. Okay, so all those functions actually seem to be there, like udiv si3, like is that in there? Udiv si3, yes. Okay, so okay, that toolchain actually has libgcc. So maybe I can do that with their toolchain. Arch. So do I just do this? Apparently not. This image reveals a special linker script. Add lgcc. Okay, that doesn't help me like at all. Basically, I'm wondering how to tell the link. Okay, whatever linking step is being run here. to include LGCC. Okay, the amount of not found symbol is huge because absolutely every file basically needs a divide or a multiply. Can I find what it's trying to do? I'm wondering if somebody has actually Linux AV32 LGTC. Okay, I have no idea what. Do we have linking steps here? That is video so install. I have no idea. Does anybody remember? What VDSO is? I mean, I guess technically I could possibly just okay. Where was the libs? Okay. I mean, that's absolutely horrible. Where we agree on that point, but if that's enough to go and go and find that lib and install and use it, I'm good with it. I'm not. Oh wow, that actually worked. Okay. Okay, that's absolutely horrible, but that's good enough for me. And so now, if we do a risk file, okay, can I have a tool chain? Obj dump. Wait, what? Oh, I forgot the dash D. Okay, we have our image, which is linked at the address that we want. And that hopefully doesn't use multiply instruction. It doesn't. Fantastic. So, we need to specify the size of the RAM. What the two things we need is specify the size of the RAM. It might be in the configuration as well. Somewhere. How does it know the size of the RAM? How does it know the size of the RAM? Okay, okay. And the other thing we need is a UART driver. Okay, gripping you out was really dumb. Okay, what is this? So there's a bunch of configs. Okay, if I edit, because there is in build root, no, sorry, in Linux, on Linux, Vectris 5, there is build root board, and there's a Linux config here, okay? I'm going to disable a bunch of drivers. Command clock light. Okay, we might actually need that. What does that do? Clock light X, let's see. What does that driver do? What? Yeah, we don't need that. Interrupt controller, yeah, we might need that. We definitely don't need network from Litex. We definitely don't need like Ethernet. We definitely don't need GPIOs. We definitely don't need PWM. We don't have iCEBreaker from Litex either. We don't have hardware sensor from Litex. We definitely don't have SPI flash from Litex. Nor MMC. So that's pretty much it. Does that, if I do this, does it reconfigure it? I'm not sure it will. Maybe actually. Yeah, I think it did. Yes. Nice. Okay, so we've disabled a bunch of driver. What console output is it using? Like, I didn't see a single driver here related to UART. Oh, light UART, okay. Oh, there is Earlycon RISC-V SBI. Okay, what does that thing do? Earlycon RISC-V, okay. Okay, that's interesting. I don't know if that's supported by Litex or not. Um, I wonder if the light UART driver supports early. It doesn't look like it does. Oh, maybe it does actually. Definitely not true for Lytics, blah blah. Yeah, I don't care. So one thing that I don't know is what's the status? Are all the IO passed through the MMU without modification? Like, can I just access the address from the thing? Okay, what I'm gonna do is basically try to patch the earlycon SBI thing to just write to. So what is that? What is UART console? Oh, okay, never mind. SBI car. Yeah. So basically, what I'm gonna do is just patch this. What does SBI console put counters actually? What does SBI stand for? Okay, so that might actually not be used in Lytex. I don't know. I would have loved if the okay, I'm just gonna replace this basically by UART code from here. Console.c. And UART base in our case is here. I can leave UART base. Okay, and here I'm just gonna write basically UART regs data equal C. And here I'm actually gonna put H to see if it even goes through this method or not. Okay, honestly, I think I'm just gonna build that, flash it, and okay, what the hell? Expected. What? Oh. Yeah, flash the image and see if it does anything. And then I certainly doubt it will, but you know, be optimistic. Oh, actually, something I need to change is the fact that this image is like 7 megabyte long, and I'm currently only loading the first 128K. which obviously means it's not gonna work. So I need to change that. Let me change that first. So how large is that image that I'm flashing? I think it's like 7 megabytes or something. Output images. Yeah. So let's flash this. So let's go with 8 megabytes. Vim boot.s. So this is currently 64K. Yeah, I need to load 8 megabyte. Somewhat significantly larger. This is gonna probably take forever to load from SPI, to be honest. But I mean, with that controller, because it's really slow controller. Is that correct? Yeah. Okay. The problem is I need to reboot the bitstream for that. Damn it. Because it's the part of the memory which is embedded in the bitstream, which does the SPA loading. So that's gonna take a few minutes. Should have thought of that earlier. Okay, well, yes, I did change the base address of the RAM. So if you look at the, so I did, oh wait, what was that? Did I do that? I did a RISC-V non-embed, like a disassemble of the VM Linux that was built, and you can see that now it's linked to go at 4, which is where we have the RAM map. So theoretically, it should execute code. Whether or not it's going to output anything on the console, I have no idea because because I have no idea. We could actually try to find where the Arch RISC-V boot, like there has to be like, okay, like loader.s. Okay, perfect. That does actually nothing. MM. Is that where they put it? There has to be like a S file which does the low level init. Okay, kernel add dot. That's probably the entry point. Yeah, jump to start kernel. So let me see, where is start kernel? Is that where I have the UART? I can't remember. 81. Okay. $36. So now if we go to that address, we should see, yeah, or debug print. So it should at least get there and execute that. I'm not entirely sure it's gonna execute much more than that, but yeah, you never know. Minicom, USB 1, megabaud. Oh, it's still running the mem test. Alright, come on, you can do it. I mean, you did it not so long ago, so I know you can do it. Yeah, I might really just remove the single shift instruction just to make it build faster, honestly. I'm not entirely. The thing is, I don't know if the like does Slytic support the SBI I mean, there's early kernel called SBI, so. Oh, maybe I need to put that in the boot args. Oh, wait. Oh, damn it. So they don't actually boot Linux directly. They boot this thing called OpenSBI. And then OpenSBI boots Linux. I don't know if that's the same, because that might be a... Yeah, that's a Vex SMP. I don't know if they do the same on the non... because, okay, I was wondering what this thing was, generating the OpenSBI binary. Oh, here there's an example. Okay, see, here, for example, there is no OpenSBI. It just boots. And technically, I don't really want SBI because I don't need any kind of platform support or anything like that. I don't care about that. Um, does it show the command line that was used here? So there is a command. Okay, there is actually a command, a kernel command line passed. I don't know where that comes from. That's actually something I don't know. Because it defines the size of the memory and yeah, because there is an option in the kernel for that, for the default command line thing, but it's not set here. Yeah, it's set to nothing. And I didn't see anything in Lytix itself. That would somehow generate and pass that command line. Let me actually clone this so I can more easily. Okay, so the command is a bad thing. Okay, not much better. Yeah, I don't see anything related to. Like where would that mem thing would come from? Oh wait. Oh, does it pass it to DTS? I didn't think it did. But where does it give it? Like, how does it pass it to the Linux thing? Here, like in the demo boot thingy, here? Okay, not that one. Here it explicitly says no DTB passed to the kernel. Oh, okay, that's a simulation actually. But I mean, even in demo here, I can see no DTB. Okay, come on. Does it have kernel arguments in there? Yeah, it does have a kernel command line. I just don't know where it gets it from. Okay. Uh, okay. So it still boots the. It takes forever to load the SP to load 8 MB, but it does it. So I'm just gonna flash what I have. It's probably not gonna do anything. But at this point it's almost 2 a.m. and I don't have much more energy left to debug like low-level Linux booting. Where did I build this? Okay, here. So ls output images. Okay. Is that rebuilt recently? 132. Perfect. So I'm just gonna flash this. Build root. Output image. Image. So what I'm expecting is actually is that image is just a flat binary. So it should start. So if we look at the debug output, we see that it starts with 6F0012, 6F0012. Okay, so that's exactly what should be loaded at 400, and that's exactly what's gonna happen if I do this. Okay, so now it's gonna take forever to flash this, but I don't know if it's gonna be tomorrow or Saturday. I don't know. It might also not be in the evening. I might actually do a stream like in the morning. I mean, in the morning for me, which is possibly not gonna be very convenient for you. But oh, okay. Okay. I need to find a way to do that then. Yeah, I mean, if I do it in the morning for me, it be something like 9 a.m. for me. At least we have progress on iceberg now. But I think I might want to also ask. I'll probably try to read some stuff about the boot process and possibly ask on the Lytix channel. To have a better idea of what I'm supposed to change, basically. If anybody has an icebreaker and a quad RAM, HyperRAM PMOD, they're welcome to do the rest of the port, right? I mean, I did the hardware part. Okay, it's almost done flashing. Are you kidding me? Reading? Really? There's a verification step? Damn it. I mean, I'm assuming lots of people have the quad RAM PMOD, right? Because, I mean, if it was out of stock, that means that some people have bought it. I actually don't have. I don't, Dimitri. I don't need to implement a command because I'm basically replacing this entire firmware that prints command. So I won't have anything. It's gonna print AB, and then it's gonna load 8 megabytes straight from the flash directly at address 0x4000, and then jump to it. So I would expect it to print ABC, meaning it's finished loading the SPI, and then it should at least print L, which is the debug character that we put like very, very early in the kernel. And then I pretty much expect it to crash. If it prints anything, I would be like very surprised, but I'm not holding my breath. It's also taking forever. Okay, well, it did finish loading, and it printed L, and then it rebooted. Okay, well, that's pretty much where we are. So it did start the kernel, technically, as in it jumped to the start kernel symbol like here and executed that and then did some stuff and crashed somewhere. No idea where, but yeah, rebooting it's a boot loop. Well, that's gonna be that's gonna be it for tonight because I'm very, very tired.